This is Pre-Algebra Chapter 3.2, Solving Equations Having Like Terms and Parentheses. In Chapter 2, we learned to use the distributive property. In this chapter, we'll learn to solve equations using the distributive property. And let's begin with a word problem about school spirit. Your school's basketball team is playing in the championship game. For the game, the cheerleaders want to buy a banner that costs $47. They also want to buy small items to give to students in the stands. Pom-poms cost $5.20 apiece. And noisemakers cost 80 cents each. The cheerleaders have a total budget of $375 for the game. If they buy an equal number of pom-poms and noisemakers, how many can they afford to buy? We can write and solve an equation to calculate the number of pom-poms and noisemakers that the cheerleaders can afford to purchase on their budget. We'll start by letting n represent the number of poms and the number of noisemakers. Therefore, 5.2 n will equal poms, and 0.8 n will equal noisemakers. Let's use what we know now to write a verbal model. We know the cost of n pom-poms will be added to the cost of n noisemakers. Then we also have to add in the cost of the banner to equal our total budget, which I'll just represent as a capital T here. So now we need to start building our equation, now that we understand what it's supposed to look like verbally. The cost of our poms was 5.2 n. The cost of our noisemakers was 0.8 n. The cost of the banner was $47. And our total budget was $375. The first thing we need to do is to combine our like terms. We have two n's in this equation, so we can add 5.2n to 0.8n, giving us 6n, plus 47 equaling 375. From here, we follow the steps that you already know. 6n plus 47 minus 47 equals 375 minus 47. 6n equals 328. N then equals 328 divided by 6, which gives us 54 2/3. Our cheerleaders can't buy 54 2/3 of a noisemaker or 2/3 of a pom-pom, so we'll have to round our answer down to 54. They can purchase 54 poms and 54 noisemakers for their basketball celebration. Now that we've worked through an example that helps us see how to combine terms, let's solve some equations using the distributive property. Negative 21 equals 7 times 3 minus x. We begin by distributing 7 to 3 minus x. Negative 21 equals 7 times 3, 21, minus 7 times x, or 7x. Now we work through the steps to simplify, as we have with every other problem we've done in Chapter 3. So we'll start by simplifying and removing our 21 from each side, minus 21. Oops, I'm a little bit out of room here, sorry. We end up with negative 42, equaling negative 7x. Now we simplify by dividing by negative 7, giving us a value of x at 6. What if, after distributing, we end up with extra terms? Let's work through a problem that has us combine like terms after distributing. We'll begin this problem by rewriting 5x and then distributing our 2 to x and -1. -2 times x will give us -2x. -2 times -1 will give us +2. And that all equals 8. Now we simply combine our terms. 5x minus 2x gives us 3x plus 2 equals 8. We subtract a 2 from each side, giving us 3x equals 6. We divide each side by 3, and x is equal to 2. And this checkpoint concludes this chapter 3.2. Try these 3 problems on your own. I'll have several more problems that let you practice combining terms and using the distributive property tomorrow. See you then.